All right, so today we're going to look at polynomials. We're going to look at how to name them, and then on the back side we're going to look at how to add and subtract polynomials, which is honestly just as simple as combining like terms. So it should be a pretty easy day here. So let's just go ahead and get started here. So a polynomial can either be a single term or the sum or difference of terms. Okay, so remember, if we think about when we were combining like terms, a term could be something as simple as a number, right? It could be like 5. It could be -10. It could be a variable. It could be x. It could be y squared. That was a term. It could be a combination of the two, like 3x squared or -4y. Those are all different terms. A polynomial can be just a single term, or it can be a sum or a difference of terms. So let's look at some different examples that are just based on some different aspects of the polynomial. So let's go ahead and look here. So the first way a polynomial can be named is based on the number of terms it has. So a single term, that would be something just like we were looking over on the side. Let me zoom in here a little bit. So a single term would be something like 3x. Okay, that's a single term. It could be something like y to the 4th power. That is a single term. It could be as simple as -10. That is a single term. Those three are single terms, and when we have a single term, we call it a monomial. The way that I've kind of explained it in the past, or the way to remember it, is just think about when you have mono, you're not allowed to be around each other. You're isolated. You're all by yourself. That's kind of the best example that I've come up with for the use of mono. So, okay, two terms. That would be something along the lines of like 3x plus 5. Okay, that would be two terms. X squared minus 3x. That would be two terms. Okay, so you can kind of see how either the plus sign or the minus sign can kind of break up a couple terms to where we kind of get two terms there, and that's when we call it a binomial. Okay, think about like a bicycle has two wheels. Binomial has two terms, and then you can probably guess then when we go to three terms, then it would be a trinomial. Just like when you add another wheel onto a bicycle and call it a tricycle. That would be something like x squared plus 3x minus 8. Okay, that would be a trinomial because I count one term, two terms, three terms. Remember, they're broken up by the plus or the minus sign, so I have one term, two terms, three terms. That would be trinomial. And anything that has more than three terms, we just kind of lump those all together and call them polynomials. Okay, with poly meaning many. Okay, so that's one way to name it. Let's look at a second way to name it based on its degree. Okay, so the degree of a polynomial is the highest exponent in the polynomial. Okay, so example 1, 6p squared minus 2p plus 7. My highest exponent that I see here is 2, so the degree would be 2. On the second example, 3x to the 4th minus 5x to the 3rd plus 7x plus 1. 7x, that has a degree of 1, right, because there's an imaginary 1 there. Just a number back here would have a degree of 0 because there are no variables with it. So I can see my highest exponent here is 4, so the degree would be 4. Okay, and we can name these things. So degree 0, an example would be, it's kind of hard to come up with examples here, but you could just do like 3. That has a degree of 0 because it does not have any variables with it. You could do -10. They could be positive or negative. They could be decimals, 5.2. Okay, but there's not allowed to be a variable with it. And we call just these simple numbers without variables, we call them constants. Okay, so it's a constant. That's degree 0. Degree 1 is when the variable finally shows up, but we have an imaginary power of 1, so that could be like 2x. And again, it doesn't matter how many terms there are, so I could have 3x minus 5. So you can see here, this is only one term, this is two terms, but they both have a highest exponent of 1. So a highest exponent of 1, we worked with these equations a lot last semester, and we called them linear, because those are the types of expressions that if we made them equations and graphed them, would form straight lines. Okay, one that is going to be big coming up soon is called a quadratic. Okay, and quadratics have a highest exponent of 2. We see x squareds in them, like 3x squared plus 4x. Or you could have x squared minus 9. Okay, it doesn't necessarily matter. Oh, wait, let me not be confusing here. It doesn't matter that there are only two terms, it just matters the highest exponent. So we could have like 3x squared minus 2x plus 9. Okay, so we could have two terms, three terms, it doesn't really matter. What matters here is the highest exponent is 2. So my highest exponent is 2, so that's a quadratic. Okay, and then highest exponent of 3, so like x to the third plus 2x. About negative 10x to the third. Okay, either of those have a highest exponent of 3. Those would be cubic. Okay, so again, we have two ways of naming them. We have the name based on the number of terms. That's monomial, binomial, trinomial, polynomial. And then we have the name based on the degree, the highest exponent, which would be constant, linear, quadratic, cubic. Okay, so those are two different ways of naming. One more thing that we need to know before we start adding and subtracting is standard form. Okay, so standard form. And this is not standard form like when we looked at graphing linear equations, when we did ax plus by equals c. This would be standard form of a polynomial, which means the degrees of its terms descend from left to right, which means they start high and go down gradually. So if I wanted to write example 3 in standard form here, I would just put the highest exponent first. So I see my highest exponent of 3 here, and so I put that term first, x to the third. Next highest exponent would be 2, so plus 12x squared. Next highest exponent would be this minus 6x, because that's an exponent of 1, and I take the sign with it, so minus 6x. And then my last term will always be just the number, because that's an exponent of 0. There are no variables with it, so plus 8. And then if I wanted to name this, I would say, okay, there are highest exponent of 3, which makes it a cubic. And there are 1, 2, 3, 4 terms, which makes it a polynomial. Running out of room. Oops, didn't pull that over with it. Okay, so again, highest exponent of 3 makes it cubic, and 4 terms makes it a polynomial. So I want you guys to go ahead and try A, B, C, and D down at the bottom of the page. So put it in standard form, and then name it based on its two names. So go ahead and pause the video, do that, and then you can check your answers in a minute. Okay, so you can see as I wrote them in standard form, I put my highest exponent first in each of them, right? And kind of go down the line, decreasing my exponent each term. Then my names, highest exponent of 1 would be linear, 2 terms would be binomial. On B, highest exponent of 2 would be quadratic, 3 terms here would be trinomial. On C, highest exponent of 3 gives me cubic, and more than 3 terms, 4 terms or more, gives me polynomial. And then on D, highest exponent of 1 would be linear, and just a single term would also be monomial. Okay? So let's go ahead and flip to the back and look at adding and subtracting. Okay, so pretty simple here. This is literally just combining like terms, and just a quick reminder, like terms means same variable and same exponent. Okay, so I'm looking for things that have the same variable and the same exponent. And remember, if I ever have any distribution I need to do that first. Most of these won't really have any distribution until we look at the subtraction ones, though. So looking here, I'm looking for same variable, same exponent. So it looks like I have a 4x squared and a 2x squared, which would make 6x squared. Remember, my variables don't change here. It's tempting to make it 6x to the fourth, especially coming off of our last unit where x squared times x squared was x to the fourth. But you can see here now we're adding, not multiplying, so we have to be careful. So 6x squared there. And then we also have 6x minus 9x, so 6 minus 9 would be negative 3, and the x stays. And then lastly we have plus 7 and plus 1, which would make plus 8. So it's simply just combining like terms. Just make sure you're not changing the x's or the exponents, okay? So you have a couple try these problems. Just go ahead and do those two, and then pause the video, do those two, and then you can start it back up for the answers. Okay, so you can see the answer on number 1, pretty straightforward. 12m squared and 8m squared makes 20m squared. And then you also have your plus 4 and plus 5, which makes my plus 9 back here. Number 2, 9w to the third and 7w to the third makes 16w to the third. Make sure you're not changing that exponent. 8w squared doesn't have anything to combine with, so it just comes down. And then negative 10 and plus 4 makes negative 6. Okay? So just one more quick thing. When we are subtracting, this is when that distribution piece comes into play. Because remember, when we're subtracting, I want to make sure that this negative that's in the middle here doesn't just apply to the x to the third. This negative applies to everything inside of the parentheses. So step 1, we always want to distribute the negative first. Okay? So if we distribute the negative first, remember this second set of parentheses now becomes negative. Let me zoom in here. So this new set of parentheses now becomes negative x to the third. And negative times a negative is a plus 8x squared, and a negative times a positive 11 is minus 11. Okay, so now I have my new set back here. Now I can go ahead and add just like I did up above. So now I have, let's see, 2x to the third and negative x to the third. So 2 minus 1 would leave me with 1x to the third left. I have 5x squared and 8x squared would make plus 13x squared. And then I have minus 3x. Be careful though, because this has an x, this doesn't. So don't just go ahead and combine them thinking, oh yeah, those are like terms. So minus 3x comes down. And then I have a minus 11 as well. So minus 11. So there is my final answer. Okay. So again, you guys have a couple, try these down at the bottom. So go ahead and pause the video. Do your couple, try these. Make sure you distribute. And then go back through and combine like terms. And then you can start the video when you're ready for answers. Okay, and here are the two answers here. So I just make sure and distribute my negative into the parentheses to make negative 9v to the third plus 7v squared and minus 3v, and then I go back through and combine like terms. Again, on number 2, distribute the negative into the second set of parentheses, negative 2d to the third, negative d squared, and then I go back through and be careful combining my like terms. Again, as you're combining like terms, make sure you're not changing exponents, okay? Not changing variables, not changing exponents. I know there's a temptation after our last unit to do that, but just make sure you don't change those. Okay, so that is it for the day.